Hi, I'm Dr. M. Kamaksha, open source software evangelist and also a full stack web developer. For the past few videos, I have been explaining about how to do statistical analysis using R programming language. In this video, I'm going to explain how to deal with control flow, because in my next video, I'm going to explain correlation. We need how to use conditional statements together with the for loops in order to perform the correlation analysis. Okay, there is one web tutorials. It is not a tutorial actually. There is a very useful book called Advanced R, written by Hadley Wickham. There are really very advanced concepts in this book. There is also a PDF file available online, but for beginners this HTML documentation is sufficient. There is a concept called control flow, and there are a number of things that which we can cover under this control flow, but mostly whenever we talk about the control flow, there are two fundamental statements that most of the time we use if and for loop instead of, there are many things, but we use only if together with for loops. For that matter, the conditional statements mixed with loops is called control flow. So when we talk about the conditional statements, one of the gigantic command used to deal with the conditions is if, and there is one statement to take care of the loops, that is for. And there are many other loop statements, statements to take care of loops inside R programming language. There is repeat, there is while do, and many other. And in if, we have if else, and then we have vectorized if. So here there are a lot of examples. Usually the syntax for if statement goes like this: if condition, if it is true, and there are two scenarios, true or false. There will be two executions. If it is true, then do this, else do the second statement. There are two conditions. The conditions tend to differ based on truth or false. The very first part of the logic is implemented based on the condition of the if statement. If the condition of the statement is true, then the very first statement is executed. The condition of the if statement is false, then the second statement will be executed. That is what I would like to explain you in precise. There is an example here. This is a very simple example where the if statement is used in order to return the grade of a given student. This example covers both if statement as well as function, as how to write the function. So here we are defining the function in which we have series of nested if conditions. The name of the function is grade, and this is how we write the functions. I covered this topic in one of my previous videos as how to deal with functions. I even wrote a couple of functions, and I have shown how to do the logic inside the functions. This function, name of the function is a grade, and this is a left assignment operator. And then whenever you are developing a function or writing a function, this is called user defined function. Now you need to write the function, and within the parentheses you have to mention the arguments. And now this is what is the logic. Your logic goes inside the body of the function. This is the name of the function, this is the definition of the function. Now this is the body of the function. Okay. Now here, if x, this input argument is greater than 90, then the grade return A. Else if the input argument is greater than 80, then return B. Else if the input argument is greater than 50, then return C, and so on and so forth. So it is very intuitive and easy to grasp the logic inside the body of this function. So when we execute this function, then based on the value supplied, the function returns the grade. That is actually a simplest example to understand the if condition inside a function in R. Like that, there are many things. Like here I said, based on the result of the condition, the R is going to execute the functions. You see here actually we are not only executing two different functions based on the truth condition, and then we are saving that result into an object called x1. So we are doing two different things within a statement. That is one advantage in R, and there are many things here, very easy. I mean, different types of examples for if condition. There is one thing called vectorized if, and this is one of the very important ways of executing the conditional statements. I mean the if statement. There is an example here. As you can see, we have a vector with, there is a vector x, and in which there is a linear number series from 1 to 10. You see here the colon operator is used. Now it is easy for you to, because if you are this far in these tutorials, I am sure you should be knowing the meaning of this statement. We are just simply creating a linear number series from 1 to 10, and we are trying to say that, not we, this x is defined in such a way that a linear number series from 1 to 10 is saved in this object. If else, so this is one of the very handy ways of using if statement in R. Other than if and nested if, there is if else statement. This is called vectorized if else function. This is a very peculiar activity available in R. You see here in this example, if else x, this is actually one of the, this notation actually represents the percentile operation, which means in most of the programming languages there is an operation to get the remainder, and different languages use different notations and symbols. Here in R we use percentile symbol repeatedly, two times together. That will return back the remainder. Here you see if the x divided by 5 and the remainder is 0, then write triple x, else as character x, something. This is actually a bullshit. You see here the first element is 1, and 1 divided by 5 is never a 0. This is you can just go back to the R and see that this is actually 1 percentile 5. So now you see what is, it is 1, it is not 0, right? Which means when you divide 1 by 5 and the result is 0.1, that is why you have a remainder 1. So since this is not 0, it returns the value of x, that particular 1, as character. You see the characters are printed in this fashion. Now this is a small example to test this vectorized if statement. So in R you have if else, nested if, and then vectorized if. So this is really a wonderful. There is a switch statement. This is another, in every programming language you have say a switch statement. This is closely related to the conditional statement, like just as if. Here there is a function and the switch statement is used. I'm sorry, this is not, okay. Now you see here actually there is a contrast between, there is a comparison between the nested if and switch statement, something like this. The switch statement is a simplified form of the nested if statement. Say for example, if you have some logic like if a is equal to a, and this is how is equal to is used in R. We are just checking whether the value in x is equal to a or not, something like that, based on This is an input, x is an input argument. So suppose if x is a, if you supply a, if we supply, if x is a, then x, and this will return the option 1. If x is b, then that will return the option 2, something like that. Now the same, actually you see here how complex it is to, so each time we have to check that condition whenever we want to return. So here in switch statement, what happens is only once you check that condition, switch x, based on the value of the x, then you just return the value. This is how. Now this is a simplified version of the nested if. So wherever you have a paradigm to, I mean, wherever there is a necessity to use the nested if conditions, there we can replace that with switch statement. So this is one simple thing, and then so there is another, you know, a little bit complex situation in switch statement. This is actually, the cow is empty, horse is empty, and dog is 4, which means that all these three represent the same value called 4. So that is how it is explained here down, the exercises. And now comes the loops, and this loop is very easy to perform in R, unlike other programming languages like C and Java, where you have to write considerable amount of code to accomplish one simple activity. If you observe this, a small example to return number series for I in 1, 2, 3, then print I, something like that. Okay, you can also initialize the value I, and then I in 1, 2, 3, something. Now do like that. There are pitfalls in that, and I mean, I'm not going to explain each and everything in this tutorial, but okay, this is all about the conditional, I mean the control flow. There are many things. Suppose this is just nothing compared to the routines we have I mean available from the VBA, Excel VBA programming. If you know anything about Excel VBA, there are more than a dozen statements available for control flow, but in R, all of them are there. Suppose if you observe, I think there is no material related to while. You see, while function loop in R. So here there is no while loop. Here you can. So there is a break statement, there is continue statement, there are quite a few things. You can do any damn thing inside R. So here you see you got R programming, same thing. I think same material. No, it's not same. That is advanced R programming. This is R programming. So you see here you have while. So while actually covers a condition and a loop. Okay, but in further you don't have the condition. That is one fundamental difference between. You see here you have the condition, and this logic is repeated until this condition is met. This is just like you know, the combination of if condition together with for and if included together. That is while loop, and there is also do while kind of thing. That is also possible in R. So this is all about control flow. Now let us go back and let's see very minimum. So I'll just clear my R and then come here. Let me use if statement. If sum 0 is equal to 0 then print it is equal. Some bullshit example. Okay, don't worry much about this. I just want to, yes, it is true. So 0 is always equal to 0, that is why you got it is equal. If that 0 is not equal to 0, okay, then it is, this is false. Please be cautious. Print this one, else. Okay, print this is always wrong. Okay, now I say this is a script, this is always wrong. So this statement is executed if it is true, the condition is true. If the condition goes false, then the next immediate statement is now vectorized if else. Now we put the condition 0 is equal to 0, then it is true, else it is not true. I don't know if it yeah, it is true. Now not equal to, I thought I have to put some print statement there. Usually it is not true, something like this. Is vectorized if, and this is just if else statement. Now nested if, let's say if, let's say A is equal to 1, okay, B is equal to 2, and then C is equal to 3. Now press this enter. Now you got A, B, C, and then if A is less than B, then print A is less than B. Oh, else if, please be cautious, else if A is equal to B. Okay, let me, we don't need C here. Okay, if A is equal to B, then print A is equal to B, then else last one we don't need. I think here we need space. Else print A less than B. Now this is called nested if. Okay, now let me print this. Somewhere I went wrong. Where? Yeah, here. A is equal to B, A less than B, A greater than B, else then A less than, A is less than, else A greater than B, sorry, greater than B. Now let's, A is less than B obviously. Now let me change this to 3, no, to 1. Now let me go to check, A is greater than B. Now let me use both of them equal. Now let's come back, A is less than B. We said if A is equal to B, yeah, if A is equal to A is, yeah, here A is equal to B, equal is equal to B, something like this. Now we have both of them to A is equal to B. So this is vector if, vectorized if. This is if else. This is nested if. So this is how we use if statement. Now coming to the for loop, I just use a simple for I in maybe 1 to 5. Start your curly braces, then print I. This just going to print 1 to 5 numbers. Yeah, that's all. You can also do anything like print this is number something like that. Okay, don't worry. I think I have to give space here. Yes. You say this is number, oh, I'm sorry. Cat. This is number no. I think I'm complicating my, yeah, this is number 1 2 3 4 5, something like that. You can also use it with print, but anyway, that's okay. So when you are combining the text with numbers, it is always better to use cat instead of print. That is what I did in this, and this is just now suppose I is equal to 10, okay, 5. Now while this is if I is less than 5, I mean print I till I is less than 5, till I is less than 5. until I is less than 5. I don't know, print I think sometimes it goes endlessly, that is what I am thinking. Print I while I is less than print I, it is not going to happen. Print I, shall we say do while. I don't think this is there in, no, this is not there in R, I'm sure. Yeah, I am expected while sorry, I is less than 5, print oh, we didn't execute it in, it's not printing actually. Okay, let's say shall we just write I, no, it's not happening. I'm extremely sorry, actually I was usually the purpose of while is something different. We have to print I, so actually the R is not able to understand what I was trying to tell it. I is equal to I plus 1. This is actually the scenario most of the time we, while I is equal to 1 initial I, or 0 you can say. Okay, let's say 1 now. So this is, yeah, so the purpose of while loop is always, there is it is just like, you know, the C style for loop. For I is equal to something, I is less than some value, I plus plus, something like that. So this is you don't have for I is equal to something like that. You can't write for, like in other C and Java, I is equal to 1, I till I less than or equal to 5, then I plus plus. This is how, and then we do something. This is C style for loop. It's simply called the C style loops, for loops. Many people, there is very hardcore fans for this type of for loop functions and loop functions, but in R, unfortunately, the for already has, the first statement has a predefined syntax. We are not supposed to use as we would like to do that by our own. We can't use as we wish to do that, and we need to follow the syntax of R. Suppose if you are thinking of using C style for loop, then perhaps you can just think of while function. So while function needs an initiation, it's the initialization of a value, some initial value, then a condition, then an increment. So this is while statement. Okay, this is control flow. I explained you the if statement, if else statement, and then nested if, for loop, and while loop. This tutorial will serve as a prerequisite for the next tutorial, in which I am going to talk about the multivariate correlation. There are many packages to do that, but I just wanted to take a very rough approach. I want to show you how to use control flow to compute the Carl-Pearson correlation coefficient. Okay, thanks for watching this video. Stay tuned to the new content. If you like my video, please press like and subscribe to my video channel. Thanks once again.